Hi, everybody. Really happy to have you here today. I would have loved to be there in person, but this is all right. Thank you very much for finding the time to listen to this talk. And I hope there's something new, interesting that I can provide you. So my name is Victor Bahl. I am the technical fellow in Microsoft. I spent a lot of time in Microsoft research, over 20 plus years. And now I recently moved over to Azure to become the CTO of a new business unit called Azure for Operators. So let's go quickly. Now, the talk is about the collaboration between cloud and telecommunication, which many of you have by now heard about. And so I wouldn't repeat it except say that both these two massive industries are doing the same thing. They're sort of like moving packets around. And the cloud industry actually has a lot of applications to it. So instead of having both of them do the same thing, it makes sense for to join forces and do it together, or the cloud networks take over some of the load, and the telecommunication companies take advantage of some of the revenue streams that come out of all this stuff. Now, to do that, we sort of have to go directly to the basic of what 5G is. Now, I listed here, and there are some numbers associated with what 5G networks are, but it's really fast. That's one thing. It's very low latency, high bandwidth, very resilient. And in order to get that, there are a bunch of technologies that have been created that I list them here. And the one thing to remember, it is sort of like adds more frequency bands, so you have a much broader spectrum to deal with. And it adds things like massive MIMO, which increases capacity and other things. Now, our response, the way we look at the telecommunication industry is that these two, as I said, the cloud and the connectivity industries have come together. And to the operators, we sort of say, you own the customers and you own the service, and you use some of the technologies that we have. So you take advantage of all the innovations that have happened in the IT industry. And so I list here just a few things that 5G can do, along with, for example, edge compute, and for example, with cognitive services in IT. And you can see the numbers that I've listed here are pretty large, and so this can all come to bear for the cloud industry. Now, in the Azure for Operator vision, we sort of think about this as a disruptive thing. Now, this is, the idea of us, for example, Microsoft was a company that did shrink wrap software, and we moved to the cloud. And that was a disruptive move, and it sort of changed a lot of things for us. And we made mistakes, and we learned from those mistakes. The same thing is sort of happening here as well. We are disrupting the way the telecommunication industry was built out with, very rigidity, and it takes about 10 years to go from one generation to another generation. But we want to add the innovative structure that the cloud brings. So we disaggregate, we take the hub and spoke model, we disaggregate into many software components, and we modularize it, and then let other people many vendors add their software module to it. Now, one of the advantages of this is that you can take advantage of because a lot of the applications, like I said, and we talk about that. You're very familiar with HoloLens, and you're familiar with xCloud as a new cloud gaming service we have. So these next generation of applications can be brought into the fold of what the operators can provide to their customers. All right, and so now this can actually go into many industry sectors. So I list here some of these sectors that you've heard about, both in this summit as well as in other cases as well. And every one of these servers can have enough 5G chip or 5G connection that then attaches to an edge, which then attaches to the cloud, and then you're able to solve all these different problems that exist. And this is just a sample to say that this is not just about connectivity in the way we sort of think about connectivity in terms of a cell phone and things like that, but also in retail, in manufacturing, in transportation, in space exploration. I haven't said that, but nevertheless, all these things can be made true. Now, in AFO, or in Azure for Operators, we actually have 3 products at this point, and I'm not going to spend time on these products. There's a lot of documentation out there that you can read about it. And more are coming as we work on this stuff. So, but for completeness, I wanted to tell you about the private MEC, which was recently went to preview mode, and this is more about an edge, and it doesn't actually require the operators, but it's an edge device that you can bring on-prem it using in enterprises. There's the mobile core. This is the well-established acquisitions we did with the firm then Metaswitch, which do the core and the voice technologies. So, and these are products that the Microsoft ships. Now, I wanted to talk a little bit about the future. That's the whole point of this. And so the future, you sort of think about, if you look at this picture, what you see is a cell phone connecting to a radio unit, which then connects to a central office, and where we can run the radio access networks. Now, these networks, there's been a disaggregation of RAN. I don't actually have time to sort of talk about how this disaggregation happened or what happened, but effectively, as I said, the hub and spoke model has been moved to a much more disaggregated, distributed model. And so you can do all of the signal processing functions that were done in hardware now in commodity software or commodity devices. So this then connects to the core, which is a lot of it is just REST APIs, and it's programming for things like session control and billing and management of other things, QoS and stuff. And then you have the network, the core network. And I'm going to say more about the Azure core network and how that plays into the 5G story. And hopefully at the end you will appreciate it, what that means. So now, in order to sort of really get deep into some of the technical things, let's talk a little bit about the radio access networks. Now, the thing about the disaggregation and the differences that is happening in the 5G world is you want to be able to save CapEx and OpEx. You want to be able to not have to deal with just one vendor or get tied into hardware. And then if you want to add more features, you can't wait for the next hardware SKU to come. You want to have the ability to be able to, just like in cloud computing, in cloud networks, be able to bring in as many features very quickly. So you want to future-proof your system. And then you want to take advantage of the management that, cloud networks are massive. And I will say something about that in the future, but they're massive and they have to be managed. And we've done that really well. And you want to bring that ability to managing the operators' networks and things of that nature. So there are many reasons why the RAN or the radio access network it gets disaggregated. Now, pictorially, if you sort of look at the architectural revolution of the RAN, on the top is what we have in 3G, 4G, which was that you had the radio unit or the cell tower that you often seen, and then that was connected to a BBU or baseband unit, which is where all the hardware existed, and then that passed on to the core, and then that was on the internet. Now, what is happening with 5G is that you take the BBU and actually split it into two parts. So you've got this notion of near edge and far edge from the cloud's perspective. And then you distribute the functionality. You call it DU or distributed unit, or CU, which is a centralized unit. And then RIC is the RAN interface controller. You can have real-time, non-real-time, and then the RU. The advantage of this is that you actually have reduced the cost of the radio. The radio is nothing now, just a device which just brings you some IQ samples. And these IQ samples are in digital form, and then from there you put the software on it and do party with it. Now, if you can do that, now imagine that as you do 5G and you deploy more and more cell sites, the cost of the cell site goes down because now you're using commodity servers and you're using a much cheaper radio units. But along with that come a lot of other advantages. I mean, doing things in software allows you to program the networks to the way you want it. So let's look at that thing and look at a few things that one has to do to be able to achieve that. And these are ongoing things, and you hear about it, there's press, but generally speaking, this is still ongoing work. And so, as I said, you have to develop the RAN. The RAN is the software module. As I said, it has classical signal processing functions. I mean, it has the Gallagher codes, or LDPC, which were discovered in the 1960s by Robert Gallagher, and now really being used. This is all done in software. And similarly, other things, modulation, demodulation, FFTs and things like that, you put them all together, and the MAC, the channel access control protocol. So you got to build one of those things in a distributed manner, and so you got to build it robust and good. So that's one of the things you have to do. Another thing is that when you build a RAN and you build it in the cloud, you need to have this notion of cloud breathing. That means the ability to add capacity if needed, to ensure you can do energy management so that more servers are not doing things that they don't need to do. So you sort of defragment and shut down certain servers, save energy that way. You also can do, you have to do software upgrades or firmware upgrades or feature upgrades, and you can do that also through the software that you build here as well. Okay, so then we go on to looking at both the DU and the CU. And here, the edge computing, you want to have RAN processing, which is coexisting with existing functions. So, in 2009, I wrote the first paper on edge computing that you may have read about. It was called Cloudlets. And then since then, we've been working on this. And cloud or edge computing was co-located with the infrastructure. The new edge is going to be where the infrastructure and the applications actually exist on the same service. And there are reasons for that. There are technical reasons, there's cost reasons, and then there are other reasons like, the real estate. People don't actually have enough real estate to put multiple servers, and there's power and energy and things of that nature. So you have to build that and make that happen. Now, once you have this, you also have to sort of build a very big trust model of security. Now, what we have done is we have disaggregated, created so many software components, and they are now vulnerable. They can be attacked from multiple places, from the inside the cloud, and they can attack from outside. And so Microsoft has done tremendous job and has taken tremendous sort of forward movement in security and trust, and you have to do that in here as well. Then you can look at, for example, programmability. I mean, I'm going to say a few words about that further, but these networks are programmable. And I mean it in a different way than what we have done with RSVP and QoS and other things that in the internet we have done. In this, the physical network is actually programmable, and we can take advantage of that. Then there's the WAN. I mean, the thing I actually mentioned, but let me say more now, is that you can reduce the latency of the last hop, but if the latency of the internet is very high, then that latency doesn't matter as much, and the scope of all the applications you're going to do is going to be limited to the last hop, because that's where the low latency is, and then the latency gets added. So you really need a well-managed wide area network, and cloud networks actually do that. They provide a very well-managed network, and they can reduce the latency across the continent, across the different planets. So we got to work on that as well. And then once you have that, you've got to sort of look at that the whole thing works well together. That means that the network does give you predictable properties. So both the wireless side and the wired side, they all give you the predictable properties you need. And then when all this is done, so this all the thing I was talking about was about CapEx and OpEx, but we can think about that you actually want to do, create new revenue. So all these beautiful applications that everybody talks about, and the new ones that are still to come, actually have to be lighted up and generated here as well. So for those who write software, this is sort of a stack picture that one might look at. And in here, you can sort of see on the vertical is the AI ML part, which is that the entire stack has got to be infused with AI and ML, technology. But let me just go through this really quickly. On the top are the consumers, the enterprise, the developers, the partners, the government. These are all sort of the consumers of the stack, and they want to use it. And then you have all these other apps, for example, the gaming app, I mentioned xCloud, or the AR, VR, HoloLens type of things. And then things we are building internally called EVS for edge video services. As you go down, you see the RAN, and you see, for example, the SD-WAN. I talked about the RAN and SD-WAN. The packet core and the voice, these are the things that companies like Affirmed and Metaswitch brought to Microsoft, and we have been actually productizing them as well. And then below is the hardware. The hardware is continuously evolving, and you've got to sort of evolve with that. Now, and then you have this sort of sits on top of all of Azure. So there's a lot here, but it's captured in this topic. Now, we have been publishing regularly, so if you're an academic, you can go and look at, this is just a sample of some of the papers that we have published in some of the top conferences. Please feel free to reach that. Now, one of the things to note is that we really want to light up brand new applications, and these applications have different demands, right? And I list these demands. Now, when 5G was created, the designers of 5G did take into account these demands, and they built a network like that. But if you sort of think about the more traditional networks, and you had to support all this, one size doesn't fit all. So there was no way to sort of give a little bit of this and a little bit of that to different applications to achieve the demands that they required. Now, so that takes us to this one problem that I kind of want to just go through, just to give you a sense of all these. I mentioned so many different problems. Let me go through one of them. So there is an idea of network slicing. Some of you may have heard of it. It's not a new concept. It's been around for a long time. But the way it is done in 5G is a little different. It's, for example, you've got wireless, which is pretty difficult to deal with in terms of like the environment cost. So, and it has resources that are like a subcarrier frequency separation, or frequency time blocks that you can be allocated to different slices to give different properties. Now, here's an example. For example, if the app has to tell it the system how what it wants in some possible way. So then you create a network slice manager, and then there you have you decide whether to admit this or not, whether you can actually provide the guarantees that it wants, and then they have the bandwidth manager. Now, one of the interesting things about wireless is that the environment changes, and so you have to have predictability in when you say that you're going to follow some SLA. You have to say within what is the guarantee. I mean, it can't be a hard guarantee because things can change. So it has to be some sort of a guarantee which is based on your prediction of how the environment is. Now, when all this stuff is available, you really have to then allocate the resources, schedule the MAC, and then ensure that, and by the way, different slices can have different MACs, so that's why I've sort of shown it this way. And then, you sort of put it all together, lump it, create the IQ sample, send it to the radio link, and then send it out. All this is done in software. All of this is sort of stuff that in computer science we've done in other places, but now we sort of bring to bear on the networks that we have here. Now here's another example of crowd breathing. I talked about defragmentation and energy management and things. So here's an example. You've got 3 servers. One is each one is managing 2 cells each. And let's say one is very hot. Now what you want to be able to do is you kind of want to be able to shift things around a little bit so that you can make it less hot and things are working better. You also might want to upgrade a server number 3, so you might want to move that into server number 1 and server 2. And all this has to happen in real time. So these are sessions that are ongoing, and so you've got state that you have to migrate. You've got you've got a very small time budget to migrate in. But you have to do this because now, for example, you have to upgrade the server 3, or alternatively, you want to reduce the energy. So we've been doing things like that. I mean, here's it's a pretty hefty slide, so I'll just say the top level words here. So we've been using programmable switches to sort of do load balancing, and also to determine like where to do the programmability of the switch itself to take off some of the CPU load and do the migration. We've also, on the right, separated the MAC and the PHY, and we have done it through a project called Orion, which will then be able to move over RDMA. So we can literally run the MAC in one server and PHY another server. And we've sort of demonstrated all these things, and they work well. And but there are many, many system challenges that you might have to think about. Now, going to the global set of things, Microsoft runs a massive global network. Here's an example of it. We have over 165,000 miles of fiber connecting our data centers. We have about 62 regions. Now, we have 120 terabytes of optical capacity, with more capacity available because we have more dark fibers. And so the thought is that we don't actually use all of that, and that's available to us. Now, the operators are doing similar things. They have similarly big networks as well, and they are spending a lot of money. We spend like $1 billion, probably more, on just managing all these networks. But we have ways to subsidize the cost or make it profitable for us, because Azure as a cloud is sitting on top. But the thing with the operators is it's a little bit more difficult. So the question is that this well-managed network can also be used for 5G. And that's the point. And so the way we sort of think about it is like, think about the physical network and then think about a virtualized version of the network. And imagine a virtualized network being available to the operators. So for them, it's sort of like, and this sort of like lumps well with their own network. So it's not just like, oh, use ours and don't use. All the investments they have made can be actually attached to the investments we have made, and then totally this becomes one single network. And there are some really hard questions here. There's network verification. This is this is really difficult. Nothing should touch the physical network that can screw it up, because it's carrying all kinds of traffic, including Azure. And then the analytics that comes back from it. These are some of the hardcore computer science problems engineering problems that one has to solve and do to solve it. We also have very quickly invested in Azure Orbital or space. And here the idea is we've got data centers and we've got receivers we've added into the data centers. So what that does is that if you have a satellite, or your customer has a satellite, or we have satellites or whatever, these satellites are moving around and they pass over many of our distributed massive number of data centers, and we can receive data from them. And then so the receiving of the data requires people have to schedule it. So for example, the customer will sort of say, okay, these are the satellites that I have, or these are the satellites that I've sort of rented out or used with edge computing actually on the satellite, and this is the data we need. And so we have the facility to suck that data in and put it into Azure Network and move it around to the rest of the world. So you can think of that as augmenting the massive network that we already have with these satellites in places where it may not be easy to get, or latency becomes a concern. And this is an ongoing piece of work, and there's a bunch of technical problems here. I kind of want to sort of say the last thing here, which is about applications. Right. So I talked about these new applications that one has to build and do. So we've been doing that for like 8-9 years. We've been focused on video analytics. And the story is sort of like you have the operators, you've got Microsoft, and you've got the SI partners. And this is a great story, because the operators can now take the technology from Microsoft, work with the system integrators, and actually provide that story. So now within the context of that, there are many, many applications one can do. These are applications that I've listed, which you can take a look at your leisure. But really, these are many of the things that we have done with the operators to demonstrate how good video analytics can be on 5G networks. Now, if you actually want to play with some of the codes, we have this thing called Microsoft Rocket, and that is available on GitHub, and it's open source, and you can play with it. And this shows some of the techniques we have developed there, plus some of the applications that have been developed on top of that. And if you want to know more and understand the more details of it, and not just be happy with this use of it, then there's a lot of papers. We've actually published close to, I was counting, 33, 34 papers on this subject in some of the top conferences dating back to 2012, when we first wrote the first paper on it. So now I'll end by sort of saying that Microsoft is very ready and willing to collaborate, and it makes sense, because we have a lot of the assets that are required to create this new future for us, where you have very, very fast applications and new generation of applications running really well over a wide area network. We have a massive wide area network. We also have some of these applications, including AR, VR, gaming, UCaaS is a unified, this is a term I kind of just wrote. I don't know if it's an industry term or not, but nevertheless, video analytics, or unified CAS is a unified communications as a service. And then we have invested very heavily on edge computing. I sort of give you a brief sense of how edge computing is evolving. Edge is going to be both an infrastructure piece as well as a computational piece, and for example, edge is in satellites and edge is other place. And this is all very well connected to cloud computing. And we know how to build software. We've built and we have the developer ecosystem to bring more and more there to all this programmability that we are now providing to all the developers. So now they can start to think about new sets of applications. And so just to end by quoting our CEO, the whole business model in this. So you see the technical side, which is where I focused on. There are many other problems here as well, and it'll take us, at least 5 to 10 years to solve many of these problems, if at all. But from a business perspective, I think I thought this was important to sort of say that. Satya has been very, very clear that this is a partnership. This is not about Microsoft taking over, becoming a telco company. We are not into that. I mean, we just want to provide the technology that can really, really flower all the stuff that people talk about and good talk about. So with that, I will end right here. And if there are questions, please send me those questions. My last name, bahl@microsoft.com, and to the extent possible, I'll try to answer them. But yeah, I imagine this to be a terrific journey ahead of us, very disruptive in bringing these massive industries together, lots of problems to solve and resolve. And that's why I moved from Exo Research to the product division. I'm really excited about it, and I hope that at least some of that excitement you've been able to sort of see, and you'll join us in this journey, and we can work together to make really good things happen. Thank you very much.